Another category of the problems in dynamics are based on the concept of the velocity as well as the relative velocity. Now, relative velocity is a concept where we will be finding the velocity of one object with respect to other. Now, this is a common phenomena. For example, when we are traveling in a car or in any automobile, then we will find that as if we are stationary and the other objects are moving in the opposite direction. Say when we are traveling in a train, then we will find that the trees and the other objects which are actually stationary, they are found to be moving in the opposite direction. Now, this is exactly what is known as the relative velocity. Because if we place ourselves in a particular object which is moving, then with respect to us, that object becomes the stationary object. That means the velocity of the object with respect to us will be 0. And then in that case, the other objects which are otherwise stationary, they are found to be moving in the opposite direction. The concept over here can be shown in this manner. Suppose the train is moving. So we have the velocity for that particular train. And there is some tree. Now, if we place ourselves somewhere here, then we can always see that the tree is stationary and train is moving. Now, when we place ourselves in the train, then what happens is with respect to us, the velocity of the train becomes 0. Now, if velocity of the train is to become 0, we will have to apply equal and opposite velocity so far as the vectors addition is concerned. And the same velocity will be applied to the entire system, even if there is some person standing over here. Then this velocity will be applied to the tree, the same velocity will be applied to the person, and effectively this velocity becomes 0 and the other objects are found to be moving in the opposite direction. So we will be finding velocity of the tree with respect to train. Now, sometimes some other phenomena also comes into picture, that is the observation that if the tree is closer to the train, we can actually see that it is moving with the higher velocity, whereas as the tree is moved away from the train, that tree is found to be moving with the less velocity. Now, this concept we will be dealing in this particular chapter very carefully. The distance phenomena may or may not come into picture. So, the topic is called as the relative velocity. The consideration that we had right now, that was when one object is stationary and other object is moving. What if both the objects are moving? For example, we have some object B moving with some velocity of B, and some other object, say object A, it has got its own velocity as the direction is shown. Now, if we are required to find, say, velocity of B with respect to A, velocity of B with respect to A, this should be read as B with respect to A. That means A should be made stationary. Now, if A is to be made stationary, then we will have to apply the velocity to A in the opposite direction, having the same magnitude, but the same velocity will be also applied to B. So, this is minus VA that we are applying. So, A becomes stationary, and then B will have the resultant velocity, being the vector addition, the resultant velocity of B can be found out by the usual law of parallelogram, and we will find that B is moving in this direction. So, this is velocity of B with respect to A. Of course, this angle also can be calculated we have got the cosine rule by which the angle made by the resultant with one side of that parallelogram can be measured